Hey everyone. Hello. How's it going? Hi. Well, okay. So today I'm solving the 5th round of Snark News Winter Series, the final round, the last one. And I have only 1 minute to start it. So I guess I'll jump straight to it and hope I get more viewers later. Anyway, yeah, wish me good luck, I guess. Okay, let's start. Let's click. Anyway. Mm. Hmm. Hey everyone. What's up? What do you think? Hi. Time limits caused by using vectors? I don't know. What's the, like, I mean, problem C should be solvable, problem D should be solvable with segment 3 bits? Should it? I don't know. I think so. Or maybe you can do square root without sorting. You actually can. But that's still pretty bad. Yeah, it is. Okay. I wonder if it was the intended solution, because I had some hard time. Did you solve it using segment 3? Or did you try square root? You had 2 incorrect attempts. I should assume square root. $183. Yeah. Sec 3 bits, okay. I guess I have to figure it out. But anyway, yeah, I mean, vectors are not too bad in general, but when you use a lot of vectors, like vector of vector, it's not too good. So in problems like this, in like square root stuff, it's usually pretty bad. Anyway, at the end it was intense. That's true. That's true. Actually, I wonder about problem C. What constraints would you choose? If not 100,000? 1 million? I wonder. Yeah, maybe n square actually. I haven't tried, but it's almost quick enough, right? But probably it's hard to push. Anyway, so what about problem C? I wonder. It's not given anywhere that the speed of the bullet is higher than the speed of all targets, right? I mean, if the bullet could be slower than the target, then it would be impossible to find the answer sometimes, right? Yeah. Hi. Yeah, it's confusing. I think that in this case it's pretty hard to solve. You have some, yeah, it's bad. But I just had to solve it, right? So I just assumed that this case will not happen. it would be still a valid problem, yeah, but there were several like reasons why I tried this, just assuming that it doesn't happen. So one reason is that everyone got accepted on the first try. Another reason is that speed of bullet is somehow at least 2, even though the speeds of targets are at least 1. And also I didn't have enough time to try anything harder than that, than the thing I just implemented. Yeah, you got the AAC for 2 ternary searches in n log square max. What's that? I mean, you mean problem C, right? So you just mean that the function is somehow, I don't know, convex? Is it? So you just check, like, you try to find the point, the optimal point using gradient descent or like ternary searches. And then if you have an optimal point, you can, like a point, yeah, I guess you can find the time you need. Again, assuming that the bullet is at least as fast, yeah, even strictly faster than the target. Anyway. Well, okay, so this contest was not too fun, I think. I guess the best problem was problem F. I think it looked fun, but I just didn't have time to try it because I just spent so much time on the square root stuff here. It's actually pretty standard, but just, you know. And then C, well, okay. Anyway. So problem A was, we have some, well, track. It's a rectangle of integers actually, and for each square of the rectangle we have like its height. I mean, yeah, so basically we have here it just says that we have a rectangle of integers, and then we calculate 2 profiles. The first profile is the maximum height of in each row, and then the C profile is the maximum height in each column, and we are given the row and column profile, and we want to find out if we can find a matrix which satisfies this. And yeah, what I did was just find the matrix. It just follows that for each integer, for each position, we cannot put number higher than the corresponding maximum in its row or maximum in its column. So the number cannot exceed the minimum of row and column. And then just check this matrix. And the question is why we check only this matrix? And the answer is there's no reason to, like, we know that Aij cannot exceed this number, but there's no reason to make it smaller because we want to satisfy the conditions on maximum. So we kind of want to maximize the numbers. So just follows that we just can check exactly this matrix. But there should be some different solutions, I think. And it should be solvable in linear time, I'm pretty sure, but I just didn't try. I guess you can solve it in linear time if you just simulate the matrix, not build it explicitly, probably. Or maybe it should be like some easy criterion, I think. Anyway, that's it for problem A. And then problem B was also not the most original one, so we had to second. Yeah, no, incorrect, this one. We had to build a graph with at most 100 vertices. Undirected graph, unweighted. So the number of paths from vertex 1 to vertex 2, simple path, is exactly k. So there should be some, like, it is enough to check max r equal to max c. Yeah, yeah, I thought it should be true. Yeah, okay. So if we check maximum of row, if the maximum of rows is not equal to maximum of columns, then the maximum of matrix is ambiguous, right? But if it's equal, then I guess when we put numbers exactly like I said, we will always get the condition satisfied, right? Sounds correct. Okay. So yeah, here let's go back. We have to build a graph where we have at least, yeah, exactly k paths. So yeah, what I did was just build something like this. We have vertex 2 here, and then we have some vertices drawn like this. Oops. Paint skills as usual. So I built the graph like this. Basically, I just built several triangles. Huh. Okay. And then from vertex 1, I just created some edges like this. So what it means is that if we don't consider vertex 1, then how many paths do we have from the red vertex? We have exactly 2 paths, right? We just go, you could go in different ways by the triangle. Okay, 2 paths. And then from the, no, from the green vertex, we have 4 paths, because we can go in 2 different ways over the first triangle and the second triangle. And for the blue vertex, we have 8 paths. And then basically, if we start at vertex 2, then we have like 1 path from vertex 2 to itself. So you can see that from each vertex on the upper side of the triangles, the number of paths to vertex 2 is a power of 2. The powers are 1, 2, 4, 8, and so on. And then, for example, if I had to solve a case like k equal to 13, now it's 11 here, I just transform it to binary. So in binary, k is equal to 1, 0, 1, 1. So, or we can say that k is equal to 8 plus 2 plus 1. So I just connect vertex 1 with vertex 8, with 8 paths, with 2 paths, and with 1 path. And that's how I get like logarithm number of vertices and edges in this graph. So it's nice. It's a nice construction, but in general, I'm pretty sure that problems like this appeared before a lot of times. So anyway, if you don't know that, then it could be nice for you. Hopefully it's clear. And the third easy problem was problem snowboard. Yeah, by the way, the contest was not very balanced, so we had 52 problems, 52 solvers of A, 44 solvers of B, and 42 solvers of E. And yeah, and then 6 and 4 for C and D and 0 for F. So a lot of people solved just the 3 easy problems. Anyway, yeah, I also have a question like skills in math competitions. It's kind of a long story, but I'm not. I'm totally not as good at math competitions, but it could be like, well, because I didn't actually devote too much time for that. Like, there are some topics I'm pretty weak at, but I guess if I just had a goal of achieving it, I could try. But anyway, yeah, I tried some math Olympiads in the higher school. And, well, in the last year of my school, I had a perfect score at our National Olympiad, in fact. There were like 3 perfect scores, I was one of them. But then I didn't go to IMO for some reasons. The reasons were that, well, I'm not sure. Let's not talk about the reasons, I guess. Anyway, I mean, IMO was intersecting with BK Cup at that year. That's one reason, and the other reason was that I was like to advance to IMO, you still have to go to like 2 or 3 training camps, and the same is true for IOI. And the training camps were like intersecting in time, so you could. I mean, also like in Belarus, I don't think anyone ever went to IMO and IOI the same year, and in many countries, I mean, I don't think many countries have that, so I would assume that. Like if the government is not used to it, I mean, it could be hard. Like it's just logistically hard as well. You just have to attend 2 camps that intersect in time, so I mean, it's hard. But yeah, that was not the question. Anyway, I guess the story is not so important. But the answer, I also did some student competitions. I went to IMC twice. And yeah. In which kind of problems do we use binary search? I mean, just look up the definition of binary search. It's just if you have some kind of function that is monotonic, or like, yeah, I mean, it's not just function. You need some kind of like condition. So you need a Boolean function, which is false for some points, false at some points, and true at some other points. And if all false points go before all true points, or vice versa, and you want to find exactly the point where the false goes into true, then you can use binary search. But you see, you went to IOI and IMO same year. Oh, that's actually very cool. Yeah, you didn't have proper training camps. I mean, I don't know. I mean, I think that we do have training camps, and also you advance to the IMO, not from the National Olympiad. You advance from training camps. So yeah. Anyway, it's really cool that you did it. Cool. Um, so problem E was about some kind of expression. We were given we had an expression with brackets and integers, and we could, like, we had some additions and multiplications, and we know that on the outer level we only have additions, like the 3, like the +3 and +2 at the end, and on the next level of brackets we have only multiplications, and then inside the next level of brackets we have only additions, and so on. And we had to calculate the value of the expression, given that we don't have the signs, but we know them just from the level of brackets. We know the sign. I mean, the solution is kind of just simulate. So we have a stack. Every integer on the stack corresponds to a bracket level. So initially I have just one integer on the stack, which is 0. So it's like on the outer level, the sum is 0. And then when I have an opening bracket, I have to add one more level. And the value at that level will be, well, 1 or 0, depending on the parity, because if I have an empty sum, the empty sum is 0, and if I have an empty product, the empty product is 1. So I just push the 1 on the odd levels and 0 on the even levels. For the closing bracket, I just check again. If I close the bracket, then this sum or product is like on the most innermost. This is already fixed, so I have to add or multiply it to the previous element. So I just do that and pop back the last element. And then if I have an integer, I just add it, or again I multiply by it on the last level, and just from the parity of the level I know what I have to do. So it's kind of, if I was given the signs, and in this case I don't have to worry about priority of operations, and if I was just given the signs but I knew that priorities are correct, and I don't have let's say I had the same priority of all operations, then it would be something similar. But here it was even simpler, because I didn't have to part the signs. I would just use the level. So it's just this kind of an easy stack problem. Any plans for future streams? Well, I guess I don't have any for now. The series is now over. As we can see, I took the second place here in the last round. We can also check the standings, I suppose. Yeah, this round is not accounted here yet, but I guess I won on total. But anyway, I mean, Kevin performed well. Well, not this time, because 2 problems failed, but he could take, even if just one problem passed for him, it would be 3rd place. If both passed, it would be 1st place. But now it's 23rd. That's one of the reasons why I don't do blind submissions, because yeah, right, you can you can just screw it up at all. You just take 23rd place, and what do you do? I mean, it could be good for you, it increases variance, right? But if I have a series of 5 rounds, I don't want to increase variance. And even this round, I'm fine with the 2nd place, because I get lots of points for the series, right? But I don't win the round. If I had the blind submission on C, for example, it could be the victory. But anyway, it doesn't matter too much. So yeah, also Radevush, who is also Stone Fang here, he performed pretty well, but well, not this time again. He had 7 incorrect attempts. Perhaps he also had square root stuff. Also, yeah, Amnik solved like won the last round. So now he has 306. I guess he took the second place overall. But anyway, I mean, it's good that we had more competition this time. We had some international competition. That's pretty cool. Even though the problems were in Russian, I do appreciate that people tried to compete even not in their native language or not in even the language they speak, just using translators. That's cool. Thanks to everyone who did that or tried. And I hope it made the series better, like at least more fun for everyone, but yeah. I'm not sure about the problems. At least this time, I don't think they were too good, but anyway, maybe problem F. Problem F looks nice. Maybe I should solve it. So at least in half a year, in August, there will be the summer series, and I would suppose I could stream that in August, but that's far from now. To find the maximum number of points which are collinear in a 2D space if there are n points. Well, if you had, like, you can do it in n cube time if you check all pairs of points, assume that you have a line that passes through these 2 points, and then you count, like, you only have to try lines which pass through 2 of the given points. So you loop over 2 given points, draw a line through them, and then for each third point, like, you check if it lies on the line, and then you take the maximum over all lines. And to make it, you can make it n squared log n if you fix the first point and then sort all the other points by angle, or just put the angles into like some hash map, and then again you can try the maximum of all angles. Google Translate was good. Yeah, I mean, actually, I'm reading the problems now, and yeah, it seems that even if I was reading the English problems, then maybe it would be fine. Like, yeah, it messes up the input format. So I guess you have to open the English statement and the Russian statement next to each other, and then like, or maybe you read the English statement and then reload the page so that it turns to Russian, and then the inputs are correct. Like here, 5x, like 5 large x's transform to x, 1 large and 4 small ones. It's just weird. In problem E, yeah, in problem E, there are no spaces now, because in Russian statement, you can see there are spaces between every pair of tokens. So it's easier to read the input. But if you translate it to English, then spaces disappear. So that's a bit sad. But anyway, if you copy the samples from the Russian statement and just read the English, then it looks pretty good. So I suppose I should try this actually next time. I think that if I stream the series, the summer series, I would just try English statements, translate into English. Hopefully it should be fine. At least since we have some international competition, it would make it like more fair to them. So should be a nice thing to do. Yeah, you translate the statements. I see. Actually, yeah, I mean, I like the feature. Like, obviously, the feature of Chrome translated to English is pretty handy here. Yes, I am going to participate at Hashcode. I'm not sure about the team, but well, pretty sure that will be the same team formation. um, like last year, and hopefully all 4 of us will get to the finals this time. Last time, Artyom couldn't get to the finals. He got his visa, but he could not fly. Like, he got his visa one day before the competition, but he couldn't fly to Dublin before the competition. That was a bit sad. And about the device for this kind of competition, I don't know. I mean, it's kind of practice, right? I mean, in general, you just, I mean, you have fewer, like, it seems like you have fewer different algorithms in the optimization problems. But other than that, I mean, just try whatever, like, just try whatever you feel is good. Like, try greedy algorithms, try DP maybe. Sometimes the problem is not solvable in, like, exactly. Like, usually if you have an optimization problem, like at hashcode, the problem will be not solvable exactly, but you could just make some condition weaker and then try to do DP. For example, if you had to distribute like some numbers into sets, then you could try to order the numbers somehow and then try to form sets from continuous segments of numbers, and then maybe you can solve this problem using DP or something like that. So there are some ideas that you just have to try, and then yeah, sometimes it works, but it's hard to say. So I would say that you need some pretty good intuition about that, but for that, obviously, you just have to try several problems, and then you just build up your intuition about what works well usually and what doesn't. Um, Thanks for introducing this series. You're welcome. I'm happy you liked it, and any other contests we should know about? I don't know. Probably not. I mean, hopefully know about all other contests. I don't think. I mean, I guess you should know about all international contests anyway. And the Russian-speaking contests, I don't think there are a lot of them. I don't even recall any other competitions that are Russian only. Anyway. So, you would like more streams. Does anyone have ideas for other contests that satisfies conditions official or interesting contests plus streamable? Yeah, that's pretty much what I'm looking for. It's just hard to stream anything, but I don't know. I mean, I would assume that anything where there's not much at stake is streamable, but it just depends. Like, what could that be? I'm not sure. But then another thing is that if it's some kind of online round that everyone does at the same time, then how do you, like, I don't really want to stream doing it because like I could do that, but all those people who will be watching will not be doing the round, right? But in general, I would prefer people to do the rounds. Why would they not do, like, why watch me instead of doing the round? That's pretty weird, right? I mean, I would suppose that, for example, if there is some official contest and then right after the official contest I do it virtually, but it's still like not the same spirit, right? It's definitely not going to be that intense like what happened in the last minutes for problem C today. I just wouldn't pull it. Code Forces virtual contests are good. Yeah, I mean, they are good. And Jim, I mean, I just don't think I'd like to do virtual contests like just for training at this point. But maybe, I mean, we'll see. Anyway, I mean, also any ideas about how to, I don't know, attract more viewers maybe? I'm not sure that I have a goal. I mean, maybe I should just advertise more, but in general, I had 5 rounds and definitely I had less and less viewership each round. That's natural because just I don't do anything unusual for the 5th time. It's hard to do the same thing over and over and keep it interesting. So yeah, in the meanwhile, about problem C, we had well, several targets and the bullet, and each target like went in some direction, and we had to pick a point where we minimize the time from the moment the target is launched and the arrow gets into the target. During the round, my stream is the same as screencast. Yeah, sure. Show it on stream for 2 hours. Yeah, I mean, yeah, that's another thing. Yeah, maybe I should just do what is suggested somewhere. It is that I just record the round. I just do the round, save the screencast, and then I just make a stream discussing what I did during the round. Maybe. Just doing it, like watching myself do it, and then also discussing the problems. That could work. Maybe I should try it. But yeah, I'll have to rethink it anyway. I hope that my round, like during the stream, like I hope that it should be more interesting to watch me doing the round on stream than on screencast, because it's online first, and so you don't know what will happen, you don't know the result. And another thing is that you can watch it with someone else, so you can discuss it at the same time in the chat. Yeah, duels should be fun. I would expect us to do more in future, for sure. Against Piotr. Who else? Who should I battle? Okay, so to finish my words about problem C, I assume that the speed of the bullet is greater than the speeds of all targets, and in this case, it means that the bullet can always get to the target sooner or later. And then the solution is binary search on the minimum time. And then when I know the minimum time, I shift each target to the point where it will be after that time. And then I know the speed of the bullet, so I know that my position, so that I will be, let's say that I should be able to hit the bullet exactly at that moment, at moment t. So let's say I have some moment t. I want to check if it's possible to get the target, to hit the target after t seconds. So what I do is I move each target where it will be after t seconds, and I build a circle around the target of radius v times t. V is the speed of the bullet, and t is the time. So I have to be at distance at most v times t from the target. So what I do next is I have several circles, and I have to check, like actual disks, and I have to check if there's a point which lies inside all the disks. And this problem, what is the best algorithm to solve this problem? What is the fastest one? Is it solvable in like n log n? Do you know? But what I did was just n cube. You just try all possible pairs of circles. You find intersection points, 2 of them, and then try both of them. Like try that point as the intersection point, because not the intersection point, but the point that is contained inside all the circles. Like if you check the area of intersection of all n circles, it will be some convex thing, and for sure it will contain at least one point of intersection of at least 2 circles. So you just check off pairs of circles, intersect them, and try points of intersection as the answer points. Like try if they are inside all the circles. And if it's true, then you have found the point. And if no intersection points are fine for you, then you just say that there are no. Binary search plus smallest enclosing circle? Binary search on what? I mean, no, I want the intersection point. Or maybe I misunderstand something? But don't I have to intersect the circles? Okay, binary search answer. Okay, just what I did in this problem. And then how was the next thing? Smallest enclosing circle? How do I have a huge template for mint? I guess I just don't like geometry. Yeah. I mean, I should write, yeah, somehow I don't have any template for point structure. I want to make one, but somehow I just can't find time for that. Or maybe can't find will. But I guess I will do. I guess I will do it. Yeah. Also, yeah, my code was very bad. In fact, I was calculating distances like 3 times. I was normalizing the points in 2 different places. I had like DDD variables, DI variable. It was so bad actually. I should have made some functions, but I was just too much in a rush. Definitely if I had some kind of point template, it would be just much easier to implement this. Yeah, it's possible only if and only if all target positions are within a certain radius of each other. Okay, okay. I see. So here we use the fact that all the circles have the same radius, right? Yeah. Yeah, that's pretty obvious, I guess. Yeah, okay. I agree. Just, yeah. Sure. Thank you. I mean, about the min templates, well, it's just some kind of template for, well, modular operations. I think that a lot of this is not really useful. Like, I'm not sure I need all of this. Maybe I can write it somehow shorter, but in general, I just have I just want to be able to do like normal operations, like when I write plus equal or times equal. I want to I don't want it to be taken modular the number. So in general, also if I write like let's say I have mint here, and then if I write 1, 2, 3, 4, 5, 6 times that. I want all of the things. Yeah, so the first one overflows because it's int times int, and whenever I do something with mint and something else, I want the result to be mint. But then I cannot just assign mint to int, or can I? No, I cannot. So yeah, I have to do it explicitly. So that's just convenient not to forget it. Non-template code was 27 lines. Okay. How long was your template code? Yeah, I guess I do need a geometry template. Especially if, like, for this series, it usually has some geometry problems, at least several. But I don't really solve geometry usually. Um, 98 total. Okay. Well, my solution is like about the same, right? But also all of this is not non-template, and also it's so ugly. My last bug was like using the wrong point here. I was using P instead of C, and again, I would just say it's just because I was too much in a rush. I just should have been I should have been too careful, more careful. Yeah. I'm a bit tired now. Anyway, so any ideas how to solve problem F? "50 characters long, are they?" Yeah, these lines are not good. Not all of them, right? Not all of them are 50 lines. 50 characters long. Yeah, so what about problems F? Problem F. So you start at 1 1 and you finish at HW, so you can have some guns. I mean, it should be not too hard, right? So, I mean, basically, when I get some gun, I mean, it's when I have some gun, it's important, like how many rows I can reach and how many columns I can reach. So, if I start somewhere, the main question is just these two numbers, like, yeah, right. And when I know the number of rows and columns I can reach, well, yeah, what I mean is, suppose I have several rows and columns reachable, and let's say I have at least one gun. Maybe I should draw in Paint again. So let's say I have the matrix. Let's say I start here, right? No, it should not be Paint, right? It should be just text file. So let's say I had some matrix. Okay. So let's say it's something like this, and maybe I have a gun here. So in this case, I can reach 4 rows, and I can reach 3 columns, right? So basically, it's something like this, right? I mean, consider all the area except this area, and let's say that somewhere in this area, except that gun I already had picked, I have some other gun. Let's say I had a gun somewhere like here, or maybe I had a gun here. Okay, so if I had a gun somewhere, let's say here, it means I can reach the finish easily now, right? Okay, bye. You'll go to sleep. Did you solve F afterwards? I guess not. But you should have solved, right? So in this case, if I have some gun here or here, I can just use the first gun to get the second gun. Let's say I will go just from here to here. Then I will shoot to the right. When I shoot to the right, I will have all this area cleared. And I will also pick up this gun, and then from the rightmost point, I will just shoot to the bottom, and I will reach the finish here, right? So if I have any guns in that area, I just win. But if I don't, then I would need to do something else. I would probably need to shoot either in the last row of the reachable area or in the last column of the reachable area. Also, there are some different cases. Yeah, there's also bad. I guess there's also some bad case. Let's say I have a gun here, and let's say I have a gun here. Now, in this case, I guess I can get it, right? Yeah, I can. Okay. Yeah, I guess it's important I start from 1-1. So that's why I can reach. So yeah, I guess it should be something like that. So it should still be some kind of BFS, but I'm just not sure about the details now. Anyway, I guess I'll go to sleep soon too. I have a contest in Petrozavodsk training camp in 8 hours. That one will be on open cup round as well. And by the way, yesterday I had my own competition, my own contest here at the camp. And it will be featured as an open cup round too. It will be on the 16th of February in 9 days, 10 days. So yeah, it will be open. Anyway, I guess I'll go to sleep now, like soon too. It's not like there are many people who are following anyway. But thanks to everyone who watches this. This was the final, as I said, this was the final stream of, like, for now, at least for the series. And I could do something in August of the same kind, but maybe I'll do something in the meanwhile to share for you, to share with you. So, hope you enjoyed your time on stream. For me, it was a fun experience. And at least one thing that happened is that I felt more comfortable each time, I guess. So That's good for me too. Anyway, streaming a dual vertical assumption, something. Okay, I will consider that. Thank you for watching. I guess you followed most of the streams, so thank you. Also for the chat activity. It's always nice that when people write in chat, right? So that you just feel that you're not alone here. I mean, I just have to talk here. If I just talk, then it feels a bit weird when you just talk with yourself. So it's nice to have interaction. Thanks everyone who watched this, and see you somewhere, sometime later. Yeah, you can see me now. So, yeah, it works. Thank you. Bye-bye.